This video will be on significant figures, this time just dealing with the zeros in those significant figures, an area that students often struggle with. So let's look at those. The first example we'll begin with is leading zeros. These are to the left of all non-zero digits, and there's a fairly straightforward rule about these. Things like 0.325 or 0.054 or 0.00378 and so forth. And the rule is zeros to the left of all non-zero digits are never significant figures. So this number has three significant figures. This zero is not significant. So three significant figures. This number has two significant figures. Neither of these zeros are significant. So in this number, all three of these zeros are not significant. The only significant figures here are 3, 7, and 8. So again, three significant figures. That rule is very cut and dried, easy to deal with. Let's consider another situation here. Zeros between non-zero digits. This would be like 305 or 4007 or 6,241,000. This rule is also fairly cut and dried. Zeros between non-zero digits are always significant. So this number has three significant figures. This number has four significant figures. This number has 1, 2, 3, 4, 5, 6, 7 significant figures. Our rule here, zeros between non-zero digits are always significant figures. Another rule, zeros to the right of non-zero digits, but still to the left of a decimal point, however in this case one that's not written. This would be numbers like 100, 330, 4,730, 5,280. If there is no decimal point explicitly written, so you don't see a decimal point here, 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 or here, even though it's understood to be there, if there's no decimal point, you cannot assume that these zeros are significant. You have to assume that they are not significant. So this number has only one significant figure. This number has two. Each of these last two numbers has three significant figures. Without an explicitly written decimal point, those are not significant figures. Zeros to the right of non-zero digits and to the right of a decimal point. Okay, in this case, this would be something like 0.0300 or 0.500, 50.00, or 4.000. Right. In this case, all of these zeros are to the right of non-zero digits, and they're to the right of the decimal point. This is actually a little bit of a special case. But in this case, the zeros to the right of the non-zero digit and to the right of the decimal point are significant. These zeros are significant, as is the 3. These zeros are significant. The 5 is, because these are significant and this is significant, you consider this 0 to be between significant figures, so it becomes significant as well. So all 4 are the case in this case. all three of these zeros are significant. So here you'd have 4 significant figures. And I'll write these down here. 4 significant figures, 3 significant figures, 3 significant figures, 4 significant figures. One last case here. This is an alternate notation, one I'm not fond of, but it's one that you sometimes see, is when you'll have a number written like 300 point, or 50 point, or 650 point, or 2000 point. When that decimal point is explicitly written in those numbers like that, it makes all of the digits significant. So it makes these zeros significant in that case. I'm not crazy about the notation. Too often people will look at a number like this and when they rewrite it, omit the decimal point. That doesn't help. Sometimes people will write it but make the decimal point so faint that it's almost invisible, and then a reader misses it. In all of these cases, I'd prefer to see the numbers written in scientific notation that makes it clear that all of the digits are significant. So write 3.00 times 10 squared, and you know those are significant figures. It may seem like overkill, but you'd write 5.0 times 10 to the first, but that makes it clear that those two digits are significant. This could be 2.000 times 10 to the third, and 6.50 times 10 squared. I'd prefer these scientific notations to just writing 300 with a dot after it. That notation is a little bothersome at times. I hope this video helps you understand what to do with zeros in significant figures. If you need to watch part of it, feel free to do so. If you have questions about any of these things, feel free to ask me in class.